Hi, I'm Janie. Welcome to our second episode of Outside the Box. Today we're going to focus on non-volatile memory express, or NVMe. As you can see, I'm solo. I don't know where my partner in crime is. Can't get a hold of him. I'm going to try giving him a call again to see what's going on.
This is Cody.
Cody, where are you?
I'm on my way. I'm stuck in traffic. It's a nightmare.
Traffic? You in traffic?
Yeah, I'm on the 101. I knew there was 2 to the 16th power parking spots, but I didn't realize there's only one exit off this freeway. Stuck in a huge bottleneck.
Well, you're going to want to get here as soon as you can because we have a really exciting show today.
Hey, let's just start it right now.
All right, well, today we've got a Lightboard Chalk Talk.
I love the light boards.
We've got a killer demo.
No better way to prove something than a demo.
We've got Howard Marks.
Deepstorage.net.
And some pretty big news.
Big news is awesome.
All right, so get over here. Let's check in with Pete Kirkpatrick to learn more about NVMe.
So what is NVMe? NVMe is a new high-throughput, low-latency memory protocol. It's been designed around the inherent parallelism in modern memories like flash and modern CPUs with many cores. It really eliminates bottlenecks in systems, and it brings back CPU horsepower that we can use in other ways in our system. We've got this really cool light board, so I thought that'd be a great way to dive in deeper. So let's go check it out. Oh, cool. This is awesome. Let's use the whiteboard to dive in a little bit about how NVMe works, and we'll contrast it with some of the legacy technology. So if we wanted to connect a multi-core CPU, and multi-core today means many and could even be hundreds, to SAS SSDs in a system today. And of course, these systems can get large. There could be many, many SAS SSDs as well. We're going to need a couple pieces of technology. So we're going to need an HBA so that we have a SCSI initiator to transfer data down to these targets. And we'll also typically have a SAS expander. And that's typically just to connect to all the drives in the system. So on top of that topology, we need to transfer data between cores and SSDs. So whenever a process running on a core wants to transfer data, they're typically going to have to navigate the SCSI stack. There's a lot of layers in the SCSI stack. They're all there for important reasons, but it does cause latency and a lot of processing to move data down that stack. And then that process is going to have to take a lock on the SAS HBA. And that starts to be the first point of contention between all the other cores in the system, because all cores are going to want to be able to do I/O. So once it's taken that lock, this process can submit a command down to the HBA, and the initiator in the HBA is going to start to arbitrate a path all the way from end to end from the HBA down to the SSD. And now you can see there's another point of contention because, again, all these cores are going to try to access all the different SSDs at the same time, and there's a point of contention on the physical arbitration. So you can see here that there's processing overhead, and there's a couple points of contention that exist in a legacy SAS system. So in contrast, we can look at the NVMe structure, and hopefully it will become clear how we can avoid a lot of that contention. So in this case, again, we're going to connect to many-core processor complex. But this time, we're going to connect down to NVMe SSDs. Now, one of the core aspects of the NVMe protocol is that these SSDs can support up to 64K queues. And a queue is just a way, think of it as a private channel between a core and an SSD for them to submit work and have work completed. So they can exchange commands and data on that queue. So the many queues that exist for each SSD allow them to have a private queue to each core. And conversely, each core in the system can have a private queue to each SSD. And of course, this is really an all-to-all, so we could start to fill in all the lines. So to transfer data between a process and an SSD, the process is going to either allocate a buffer in memory, or if it's a write, to actually place the data in memory. and then simply ring the doorbell on one of these queues. And from there, the DMA engine in the SSD knows how to do all the work to transfer data from main memory down to the SSD. Now, because this work is done all in parallel and all on different queues, there's no contention between any of the cores, and likewise no contention between any of the SSDs. So the benefits of NVMe can be extended outside of the system as well. And I don't have enough space to draw here, but you can imagine that with NVMe, and especially if it's transported over fabrics, there's going to be a way to connect to the entire data center in such a parallel fashion. And that's a really exciting development. Well, this worked out really well. This is really cool. I can't wait to tell Bill, who I worked with on this project, all about this cool whiteboard. Hey, Bill.
Hey, Pete.
Have you seen that digital whiteboard?
No, I haven't.
It's awesome. I was just using it to geek out with the audience about some of the details of NVMe.
If you think about it, NVMe is the first storage protocol that was designed specifically for flash.
Yeah, it's really easy to get excited about some of these low-level details, but it's really cool when you think about how we can build up a bigger system that can do more work.
With the components being faster, you can make a more efficient storage system. You can have more performance and have greater consolidation, which is great for the customer.
Well, that should really save people money, space, and power, and everybody loves that.
That's a big win. Let's go to an outsider's perspective from Howard Marks on the transition to NVMe. I'm here with Howard Marks, the graybeard of storage from Deep Storage. Howard, thanks for coming today.
It's my pleasure, Bill.
So Howard, what do you think of NVMe?
I'm really excited about NVMe, and the short form is it's faster, stupid. That NVMe is a cleaner path from the processor, whether that's the processor of a server or a storage system controller, to the flash memory. And we can now treat that flash memory more like memory than like a disk, because frankly, the SAS and SATA interfaces just have a lot of crap associated with them.
So NVMe is really applicable to a lot of different technologies, but where do you see it being deployed?
I'm seeing NVMe deployed everywhere. Right? If you bought a new laptop in the past year or two, the SSD in that laptop is likely to be a PCIe NVMe SSD. If you deal with the hyperscalers, the Facebooks and Googles of the world, the servers that they're installing to run their applications have NVMe SSDs in a PCIe slot in the system. The servers that are coming out lately have slots I can plug a 2.5-inch U.2 SSD into, so I can have all the performance advantages of NVMe and the hot swappability that the enterprise guys really like.
So how do you see NVMe affecting enterprise storage?
So NVMe is affecting enterprise storage today within the server, so that those applications that can deal with local storage can now use a PCIe NVMe SSD. Over the next couple of years, we're going to see NVMe as media introduced into storage arrays. So we'll have lower latency from the controller to the media in the storage array. It means the storage array can offer lower latency to the applications.
So NVMe being deployed in the enterprise is really exciting. And then the next step for NVMe is NVMe over fabrics. Where do you see NVMe over fabrics going?
Today, NVMe over fabrics is a niche solution. It's kind of like a top fuel dragster. Those systems go really fast, but the engine blows about every 10th run down the track. And enterprise guys really like to keep their data safe. And it doesn't turn. And so the equivalent there for a storage system means that the storage system has no data services and isn't very reliable. There are applications for that, like high-frequency trading, where every microsecond equals dollars, but it's not a mainstream product.
Wow, we've been hearing about NVMe now for 2, 3, 4 years. When do you see the transition? When do you think NVMe really starts to get adopted widely?
I think that the real transition to NVMe is starting now, and that the tipping point comes in 2018, year after next. At that point, a sufficient number of storage systems will support NVMe media Curiously, the Pure M series was designed for that. And when I first saw a presentation, I looked at it and I said, when are you guys putting NVMe in there? And then I did some more research and discovered that the SSD guys weren't ready for you to do that. But 2018 is really the tipping point.
Great, Howard. Thank you so much for giving us insights on the transition. Could talk with you all day about this.
Well, that would be great, but unfortunately, as usual, I've got a hard stop. I got another meeting I got to go to, so it's been fun chatting with you, Bill.
All right, thank you.
You're welcome.
So this transformer is an interesting concept. As a parent, I can buy it for my kids, and I get a truck, and I also can convert it into a superhero. At least they can convert it into a superhero, even if I can't. Point is, you get two for the price of one, and you get that power of change. So change or transformation is one important thing that we considered when designing our Pure storage arrays. The second thing is future-proofing. So, as an example of future-proofing, when I built my house, I put electrical outlets next to all the toilets. The thought was, hey, someday we may want to put heated seats on the toilet, so we can put an electrical outlet there in case we want to do that later. And that's an example of future-proofing. Pure flash arrays are both transformative and future-proofed. When we started the company, we were doing all flash, and our goal was to deliver all flash for everyone, to make flash not an exotic thing, but an everyday thing. Now we're transitioning from SAS to NVMe flash. And that's an aspect where, a lot simpler than I can transform this from a truck into a superhero, you can transform your storage array from SAS, which was a disk-oriented protocol, to NVMe, which is a solid-state-oriented protocol. I often tell customers, you can buy our smallest array today, transition seamlessly to our biggest array 6 years from now. I don't know what that is. There'll be some new technology change. Maybe it's 3D XPoint, maybe it's something else that nobody has yet imagined, but you'll be able to change your Pure storage array from SAS to NVMe, and then from NVMe to the future, a lot easier than I can change this transformer. So that's what we set out to do now, and it's exciting to see us going from SAS to NVMe with our flash arrays.
Hey Pete, how's it going?
Good, how's your weekend?
Whoa,
Oh, look at that.
cool.
It's a transformer.
I've seen one of these in years. Let me check it out.
That's awesome.
That's really cool. So I've heard there's lots of cool transformations happening up here. I didn't really know it was raining transformers.
That's
but
right.
I wanted to come up here and check out the new NVMe Ready M.
Got it right here.
Yeah, it looks awesome. So from the software side of things, we're super excited to get more NVMe Ready Flash modules.
That's right.
We were really excited when we got the NVRAM because it allowed the massive amounts of parallelism that we have in Purity to take, to use its capacity.
Yep.
So I wanted to see what else you've got coming up.
Well, so you mentioned the NVRAMs. This was really one of the first modules we designed into the system. They've always been shipping with the M. And NVMe and these modules really broke some bottlenecks for us. So they allowed us to achieve much higher write throughput, get lower write latency, and that's a big benefit for end users.
So I see you just taking it out here too. So these are hot pluggable?
Yep.
And I've heard that when you start hot plugging things, stability becomes an issue. How stable is this setup?
So thanks for asking. I'm really happy to say that
You're welcome.
we really worked a lot on this. And when you own the whole system and you own the endpoint modules, the platform all the way up through the software, you really can harden everything and to make sure that everything is stable in hot plug. And so now we're going to take our experience from that and make sure that we can support NVMe in all the flash module slots.
Awesome. So if I was a customer and I had a setup like this, which is here full of SAS modules, right?
Yep.
And I wanted to expand my capacity so that I could use this awesome new technology that we've built, how would I go about doing that?
Well, it's easy. So the system's not online, but we can walk through what a customer would do.
Okay.
All we have to do is pop out these flash modules one at a time and put them into a shelf that's connected to the system. and they remain part of the array.
Yeah, so Purity's already optimized to handle this. What we can do is when a drive has been hot plugged like this, we detect that the segments on that need to be repaired. Now, the really cool thing about the software, though, is that it also detects when a drive reappears. And when that happens, we notice that we can cancel any sort of repair that we have in progress. So what that means is that we can move these drives non-disruptively without any performance implications to the customer. So now that we've got all of our SAS modules down here into our expansion shelf, what's the next step that we need to do?
So the next step is just to upgrade the controllers from SAS to NVMe. So we can pop the old SAS controller out and pop the new NVMe controller in.
So the great thing about this is during this time, Purity is up and non-disrupted during the entire controller swap. A failover occurs, but nothing is visible to any of the end users. So Pete, now that we've done the controller swap, what's the next step?
So now that we've created space for this expansion, we can pop in the new NVMe flash modules.
Awesome. So while he does that, we can talk about the fact that this is one particular upgrade scenario where a customer has upgraded both their capacity as well as to the NVMe ready modules. There may be other options, but we have different stories for those as well. So the great thing about this is the customer now has different options. They can choose to continue to use their SAS modules down here in the expander pack, or because we've just expanded our capacity, we can roll all of the data back up into the NVMe drives to get more access to some of that performance, all non-disruptively, all without any performance impact. So easy.
That's all it takes.
All right, Pete, now that I saw this, I want to see what's over there.
Oh, I can't show you anything
Are you
else.
sure? I'm gonna go look. Dino, see if you can check it out.
So I think it's cool to show they're not only innovating in the underlying storage, the software on top of it, but also...
I love these things.
Oh, speed transformer. Give me this.
That's mine. It's mine.
Fine, but that's strike one.
Okay. Well, while we sort this out, let's hear from Sandeep with a customer story.
Non-disruptive upgrade path to NVMe. Does that sound too good to be true? Well, let's hear directly from Brian Booth from Paylocity, an early customer of Pure Storage Flash Array, and Brian has directly experienced multiple generations of Evergreen storage upgrades. I've got Brian lined up here on a video chat. Hey Brian, how you doing, buddy?
Hey Sandeep, how you doing?
Brian, let's jump right in. You have had the chance to experience Evergreen storage and across multiple generations of flash arrays. Give us a color on what has Evergreen meant for you, for your business, as well as the IT department at Paylocity.
So it means that we're able to grow our arrays as we need more capacity, more performance, without the pain of tearing them down and forklifting new ones in.
And what are the generations of flash arrays that you've been able to experience?
So we started with a 300 series, and then we went to 400, we went to 450, we went M70, M70R2. So we've had pretty much the whole gamut.
And essentially when you started with the 300 and transformed it over multiple generations, all the way into a flash array M70. Was that done completely online without performance impact and kind of keeping that same array effectively intact?
Yeah, we kept the same soul of the array. It was great because it wasn't disruptive, that there wasn't downtime. We were able to upgrade it once, then upgrade it again, and upgrade it again, and it was a minimal time sink on our technical teams.
So let me get this right. You're saying you were able to go through multiple generations, I'm assuming along the way, get performance increases, scalability increases, all of that, just done non-disruptively.
Yeah, absolutely.
Well, fantastic. Your flash array M's are NVMe ready. What does NVMe mean for Paylocity and the fact that you'll be able to get there completely non-disruptively with Evergreen storage?
NVMe is an exciting technology. It's something that we feel kind of future-proofs us because it promises lower latencies, it promises higher throughput, and as a growth company, that's something that's really important to be able to take our infrastructure and grow with the organization.
Brian, thanks so much for joining us. Love that you were able to spend some time with us.
Great to talk with you. Thank you.
So I think we've learned some exciting new things about NVMe today and outside the box, but I think with that, it's time to wrap it up and head home.
No, not quite yet. Where do you have to be?
I
go?
have my TV.
Traffic?
There's
You're
it's
gonna
a
be sitting in
mattress
traffic
and
all
280,
night.
but just
No.
slow things down a little bit.
He's not going anywhere because we have one last thing for you guys.
Let's summarize what we've heard so far. NVMe is going to be awesome for your applications and storage overall, and it's coming sooner than many think. Pure Flash Array was born NVMe ready, and anyone buying storage today needs to future-proof it for NVMe.
That's right. NVMe is just another day in the life of Evergreen storage. And as we saw from our customer example with Paylocity, this Evergreen model, it's a reality, not just theory.
So some of you may be wondering, is Paylocity unique? Will NVMe be seamless for all?
Well, guess what? Turns out it will be seamless for all. We are so confident in this Evergreen upgrade to NVMe that we guarantee it.
That's an industry first. If we don't somehow deliver on the Evergreen upgrade promise, we have a remedy that customers will love.
That's right. If that upgrade doesn't work, we'll replace your existing array with an equivalent 100% NVMe array, free.
One way or the other, investment in Pure today gets you to NVMe in the future. That's the Evergreen promise.
And that's the news, and we've reached the end of this episode. So stay tuned for the next episode of Outside the Box, where we're going to unpack what it means to be effortless, not just easy, and we're going to dive deep into Pure One, our cloud-based management and support offering. So I think, Sandeep, there's only one thing left to do here.
Yeah, let's dance.